Okay, now we're talking about the distributive property. And again, I think this is probably something all of you have seen at some point, but just in case, here it is again. So distribution is basically used when you have terms in parentheses that cannot be combined. So when we were doing order of operations, we looked at parentheses first and just kept doing all of the operations within the parentheses until we got ourselves to just one number. So if I look at something like this, 10 times this quantity, 3 minus 5 times 2, all of the terms in this set of parentheses are like terms because they're all constants. They're all just plain regular numbers. But if I look here, in these parentheses, I have 3 minus 5z. These are not like terms. 3 is a constant, but negative 5z, this is not constant because what this term is worth depends on what the value of z is. So I can't combine these. So when I can't combine what's in parentheses and I have a situation with multiplication, that's when I have to use the distributive property. So again, if I were going to do this, I would still follow my order of operations and I would have 3 minus 10. I'd recopy this, and 3 minus 10 is negative 7. And then 10 times negative 7 is negative 70. That's what we've been doing. But here, I can't combine these terms, so I have to distribute. That just means rather than multiplying 10 by whatever this ends up being, I'm going to multiply 10 by each of the terms in the parentheses. And this is when I really have to be careful of what signs I'm working with as well. So the first thing I do is 10 times 3, both positive, which is positive 30. Now I'm multiplying 10 times negative 5z. I can kind of forget the z for now. I'm going to think 10 times negative 5. That is negative 50, and that term gets the z. Now, here I could keep simplifying because, again, everything was like terms. Here, I cannot. I can't do anything else. I can multiply all I want with unlike terms, but I can't add and subtract. I can't combine unlike terms. So that's as simple as this answer is going to get. So as I go through these examples, I'm never just going to get myself down to one number, but I'm going to get myself as simple as I can. So again, in here, I have a 4y and a 3z. Since these variables are different, they're unlike terms, I can't combine that. I can't call that like 7yz. They have to stay separate, so I distribute. So 3 times 4, both positive, is positive 12y. I have a positive 3 times a positive 3, which is positive 9z. And again, this is as simple as it's going to get because I cannot add these together since I have unlike terms. In that case, I would just be done. Over here, I can't combine 14 plus 2x. One is a constant, a regular number, the other has a variable. So I have to distribute. Positive 10 times positive 14 is positive 140. Positive 10 times positive 2 is positive 20. And that term gets my x. And again, that's as simple as it's going to get. I cannot combine these because this term has an x and that does not. Here, I actually have 3 terms. I have an x, a y, and a z. So I cannot combine any of those within the parentheses because they are different terms. I can't do it. So I'm still going to distribute. So positive 3 times positive 4 is positive 12, and that gets the x. Positive 3 times positive 10 is positive 30, and that gets the y. Positive 3 times negative 3 is negative 9, and that gets the z. And that's as simple as it's going to get. Here, what I have to distribute is a negative 7, so I have to be real careful about that. Negative 7 times positive 6 is negative 42, and that gets the a. negative 7 times negative 2 is positive 14. And that gets the B. When I look at this, there's a few things going on here. And I can actually do this one of two ways. But I'm going to keep with the spirit of the distributive property for now. Now this out here, sometimes people just are like, I don't even know what that is. It doesn't matter, whatever. It does matter. You're technically distributing a negative 1 to every term in here. So if you need to write in the 1 to remember that that's what you have to do, then go right ahead, okay? So negative 1 times positive 5 is negative 5, and that gets the A. Negative 1 times negative 3 is positive 3, and that gets the B. Negative 1 times negative 10 is positive 10, and that also gets a B. On all of these others, once I distributed, I had no like terms, so I was done. But here, I do have a set of like terms. I have a 3B, positive, and I have a positive 10B. So I am going to combine those. I still have this negative 5A, and then positive 3 and positive 10 is positive 13B. Technically, I could have combined these B terms inside the parentheses. That would have been negative 13. And then I would have multiplied that negative 13 by this negative 1 and still gotten 13B. So that's basically the idea of the distributive property. You're using it to still be able to do the multiplication of what is inside the parentheses when what is inside the parentheses cannot be combined. But at the very end, you always want to make sure that you've combined any like terms that you could. And on these examples, that was the one where we could. And that is the distributive property.